All right, so we're going to talk about engineering ethics. So engineering ethics. Engineering ethics are different than those of personal ethics and common morality. Personal ethics are kind of what you hold dear. Common morality is what most people think is okay. Ethical commitment is central to most actions in engineering. So when we think about what we're creating and what we're using, um, it should be focused on positive ethical results. We may have conflicts between engineering ethics, personal ethics, and common morality, and this happens more often than you would actually realize. And it's just part of life, and you have to navigate that as you go through. Um, the core of engineering ethics, though, should lay around the central theme of preventing disasters and professional misconduct and producing a better life for mankind. That's really kind of what we're looking at. So there's two models. Let's talk about the business ethics, business model. It says make the maximum amount of profit for a company within the constraints of the law. So I kind of have a problem with this one, and I'll explain why. So talk about the housing market crash in the 2000s. What was happening is they would say, "Hey, Colin," banks would with loans say, "Hey, Colin, you make $4,000 a month. I'm going to give you a loan for a house for $3,000 a month because that's what you can afford." The reality is there's no way I could afford that house payment, making $4,000 a month, because I have a car payment, because I have insurance I need to carry on the house and the vehicle. I have utilities to pay. I have to have food to eat, gas to get from A to B to my job. So what they were doing is giving loans that were high interest and much more than a person could afford, hoping that they would actually make the payments to make the bank more money. But what actually ended up happening is people started defaulting on those loans because they couldn't actually afford them. And then the housing market just crashed and the economy went into a recession because of it. This is where people had to, like the US government had to bail out banks and the automotive industry. It was a very messy time in the 2000s. Then we have professional ethics. These are the ethics in which doctors, lawyers, teachers, and engineers fall into. Simply put, the occupations have an implicit trust put into them by the public and therefore have a responsibility to the public. Um, so, what is implicit trust, you may ask? It's an implied trust. We trust that a doctor is doing their job properly, not to harm us, not to kill us. They're giving us medicine that's going to make us better or help us. Um, so these are the kind of things that we're looking for with professional ethics. But lawyers, they're covering our butts when it comes to the law. You know, engineers, when you drive across the bridge, it's not going to collapse. These are things that we look at for um, uh, professional ethics, as we see ourselves as professional. So common ethics is a set of beliefs shared by almost everyone. You know, don't kill, don't steal, um, be kind to people, you know, all that kind of good stuff. A lot of it comes with the areas we live in. It can come from, you know, also family. And then you have your own personal ethics, what you actually see to be true. Like in personal ethics, that's normally where you have like gray areas. So like, don't steal. I'm all for not stealing. But if I have starving children and I don't have a job and I have no way to get them food, I might think about stealing a loaf of bread or something of that nature. Um, so that's your personal ethics, what you hold dear. And they can be different than common ethics, and in some cases they are. Like for me in this area, since I grew up in a different area, I do have some different personal ethics than what the common ethics would be for this area. Professional ethics. These are a set of standards set forth by a professional group insofar as they view themselves as professional. Society of Automotive Engineers is an example. They have an ethical statement talking about their responsibility as engineers in the automotive industry. So let's look at when negative things happen. So DC-10 was a McDonnell Douglas airplane. It had a rear door with steps, and the company knew through testing there was a chance that rear door would open while in flight, depressurizing the plane. But they were like, should be okay. And whenever an engineer says should be okay, that's not awesome. Okay. And so what eventually ended up happening, they had a couple incidents, but no one crashed, and finally a plane, I believe it was over Egypt, crashed, killing all the people on board, all because they didn't want to own up to they had a problem. Challenger was a NASA failure, and that was more of a PR reason. They were running. I think we've already talked about this in class with the Challenger, but they were behind schedule. There was a lot of publicity about putting this teacher into space. NASA was trying to show off what it did, so it decided to launch a space shuttle after a huge cold spell that it never launched a shuttle in that kind of weather. Never would have. But because of PR, they're like, yeah, even though they were aware that something may go wrong. In the case, an O-ring in one of the rockets didn't seat properly, causing it to basically fill up with fuel and explode, and killing everybody on board. The Columbia was another NASA issue with same thing, that it's knew that these pieces of foam would break off the booster rockets, or the rockets, as it was going into the air. And when I say foam, we're not talking about like spongy foam or the foam packing a TV. We're talking about super hard. I mean, foam is just nothing more than a cellular structure, like super hard foam, like bricks. And it ended up hitting one of the heat shields underneath the Columbia. And again, they knew that something like this could happen. And underneath the Columbia, and as it was coming into reentry, that heat shield that was compromised caused the entire shuttle to be burned up upon entry again, killing everybody on board. Yeah. So let's talk about positive faces of engineering. So sealed beam headlight. Now this is something that we all actually have now. All headlights are sealed beamed, and that they are normally have gaskets around them, and even the bulbs, to keep moisture out, because moisture would fog the lenses, basically inhibiting the ability for that light to shine through. So one of the big automotive makers decided, hey, what if we sealed the light in? And when they did it, it eliminated that fogging, allowing, and especially if you think about Northwest Ohio, we have fog and condensation a lot. It's very humid in our area because we live in a swamp. That would be a real problem if it weren't for sealed beam headlights. Airbags, these were not normal things back in the day. I remember sitting on my grandpa's lap when I was probably like 4 or 5, like literally while he was driving down the road, and things have changed. They're made in conjunction with seat belts. Seat belts have been around, but to also complement seat belts, so that if you are in an accident, the seatbelt restrains you, and the airbag cushions that blow, so you don't go through a windshield or you don't go out the side. Like cars are covered in airbags. My SUV has airbags in the front and the rear, on the sides. But again, just made to protect people, not for profit. Let's talk about advanced neuroprosthetics. They have made amazing advancements over the last 20 years. Unfortunately, because we've been at war for quite some time, and a common thing is an IUD or IED that would leave soldiers maimed without limbs. So they've been in a lot of work, advanced neuroprosthetics, where they'll actually implant into the brain onto, let's say, an arm or a limb. And that is so they can move it like they would if they had an arm and limb there, making learning how to use it again much easier with much less hassle, and super good stuff. Taking a negative and turning it into a positive as much as possible. So why do we want a positive ethical approach? We need to look outside the motivation of profit. Profit is a byproduct of a good, well-intentioned product. You want to help somebody. You want to design a better motor, or install a better security system and software. These are things we want to do. They look to better humanity, and because of this, it increases both output and quality of the work of the engineers themselves. So a little project that the engineering students had here at Northwest State with myself involved was helping a kid that was missing a hand, kind of help a mechanical assisting device on his hand so he could, have a better life. Like, we didn't make any money off of that. We simply did something that we thought would be right, and we worked longer hours. Nobody got paid, but at the end of the day, like, we changed somebody's life, and that's kind of cool. That keeps you motivated. And the quality of our work. We wanted to make sure that this thing worked, and we tested it, and yeah, it's good stuff. So, responsibility engineering. Engineers are responsible. Responsibility is accountability. This pertains to the past, present, and future. So products that we made yesterday, products that we make today, products that we make 10 years from now, we're all liable for. Like, this is something we're responsible for. I remember with the company I worked for, they had done some work with a stadium seat manufacturer, and in one of the stadiums, it was a deep red color is what it was. And basically after 3 years, it was turning like flamingo pink. All right. And the sports, it was a football stadium, was like, this isn't what you promised us. So they went and sued the manufacturers of the seats. And the manufacturers of the seats were like, oh no, this is a additive problem. So they tried to sue us. As we found out, they didn't use the appropriate amount, and it was actually their fault. But had we messed up, we would have been responsible for the damages, replacing that material, paying to replace the seats, and all that good stuff. All right. So past, present, and future. Engineers not only have to adhere to regulatory norms and standard practices of engineering, but also satisfying the standards put forth by the public of reasonable care. All right. They expect when they drive across a bridge that it's not going to collapse. They expect when they are in a building, it's not going to break. They expect your engine not to explode. Like, all of these things. They expect your computer systems not to shut down, or the programs you created not to create a virus as well. They're looking for us to do what's right by them if they're using the items, what people would consider reasonable. Engineers will be held accountable, if not legally liable, for negligent and reckless harm caused by faulty design and implementation. So, like, we could be held legally liable. It could be like, hey, you did something that hurt people, and not only the company's liable, but you could be liable as well. So responsible engineering practice requires good judgment, just not calculated results, such as if I'm building a hoist, an 8-ton hoist crane. I'm going to make sure that it holds more like 16 ton, because I know my calculated results may be spot on, but you need to put enough safety factor, because you don't know if they're going to overload it by just a little bit, or it's going to get tweaked just a little bit. So my calculated results aren't good enough. I've got to go a little bit further to ensure that what I'm doing is correct. And a good test question for an engineer is, what does an engineer do when no one is looking? Normally, engineers only work in small groups, depending on where you work, obviously. But most people can't understand actually what engineers and technologists, such as IT specialists and programmers and all of that good stuff, they really don't understand what you do or what we do. So, could we fudge numbers? Could we lie? Could we change some things? Of course. Whatever, could it be fine and no one ever knows? Absolutely. But we don't do that, okay? Because we're ethical engineers, and when no one's looking, we're still doing the right thing. So, things that impede responsible engineering self-interest, like, oh, I get a bonus if I get this out, so the numbers are a little bit off, it's fine. That's self-interest. Fear, hey, I don't want to go to my boss and tell him I lost, I made a $100,000 mistake. I don't want to lose my job, okay? Self-deception, that's where we go, I'm sure it'll be fine. Like, it's okay. Like, you know what? It's going to be just fine. All right, that's when you're deceiving yourself. Ignorance is literally you just don't know. But if it's willful ignorance, you don't know and you're not going to look. that impedes responsibility. Okay, like it's all right not to know, but if you need to know, you better take the time to figure it out. And because engineers and technologists and we tend to be a little bit arrogant, we tend to have a little egocentric tendencies. Like I can't possibly be wrong. Yes, you can. All right. So you need to be aware of that and be aware of your own egos. Narrow vision, that's where like you just are so focused on this one little piece. You're focused on this like one little problem over this much larger problem that you forget to look anywhere else. I've done that with math. I'm like, oh, I must have messed up right here, right here, right here. Somebody else walks by and looks at, three lines down your page and like, no, you messed up right there because you were so focused on one thing, you didn't think of looking elsewhere. Uncritical acceptance of authority. That is where you look at authority as like they must be telling the truth and know all without thinking, does that make sense? Like with politicians, like you should ask the question, is what they're saying like doable or does it make sense? Same with even teachers. Like if the teacher's saying something it's not quite jiving with you, ask a question. And any good teacher will answer your question. Be like, oh, you know what? I never thought about that way. Maybe I am wrong. Or, hey, no, here's some more information that'll help you. And then groupthink, that's where people are afraid to kind of stand out. You see it a lot and when you ask like students a question, hey, is the answer A or B? And then you get about 80% of the class that raises their hand for A. And then all of a sudden, you get the rest of the class that finally raise their hand, and then you go, oh, nope, it was B. And you'll have people go, I knew it was B. Well, why'd you raise your hand then? Because they didn't want to feel left out of the group. That's groupthink. All right, so that's kind of an introduction to engineering ethics. There is an assignment associated with this, which is posted. And let me know if you need anything at all, and I'll talk to you guys soon.